Hi, you're listening to Stephan Livera podcast, a show about Bitcoin and Austrian economics brought to you by Swan Bitcoin. Now, Swan has a new offer I'm excited to share with you. For those of you who are US residents or taxpayers, Bitcoin is generational wealth and you can secure your bright orange future with the Swan IRA. It's real Bitcoin, no taxes. Swan offers both traditional and Roth IRA options to best fit your needs. You can create your IRA and start adding Bitcoin in less than 1 minute. Transfers and rollovers are available, and Swan's Bitcoin experts will get you set up with no transfer fees and no minimum balance requirements. This is real Bitcoin, not an ETF or other derivative. Get the real thing and get it at Swan. Go to swan.com/IRA for details. Mempool.space is my favorite Bitcoin explorer, and I use it regularly when I'm about to target the fee for an on-chain transaction. Mempool.space is a comprehensive Bitcoin explorer that allows you to see various aspects of the ecosystem, whether that's the mempool, the blockchain, or second-layer networks like the Lightning Network. With Mempool.space, you don't have to trust a third party. It's free and open source software. You can host it, you can run it yourself, and you don't have to trust other people. Now, if you're with an enterprise, you can use Mempool.space with a customized mempool instance. You can have your company's branding, you can have increased API limits, and more. Go find out more at mempool.space/enterprise. Are you ready for something big? BTC Prague is coming June 8th to 10th. So make sure you take out your diary or your calendar, mark those dates, look up flights, look up hotels. This is going to be the biggest Bitcoin event in Europe. So if you're in or near Europe, I really strongly recommend you come along for this one. They are looking to have 10,000 people coming along. Now, maybe 3,000 or so of those people will be people who are already Bitcoiners, and let's say those 7,000 people might be newer to Bitcoin. So this is a fantastic opportunity to connect with other Bitcoiners. There is an awesome lineup of speakers. Michael Saylor himself is coming, as well as a range of other people. I will be there. I'll be one of the MCs, and I'm looking forward to seeing you there. Get your tickets over at btcprague.com. Use code Livera for a discount, and of course, if you pay with Bitcoin, you get a further discount on your ticket. That's btcprague.com, June 8th to 10th. Now, for the episode today, my guest is Calvin Kim. He is a BitMEX and HRF grantee. He's joining me to talk about utreexo. So utreexo can massively make the UTXO set much smaller. So this could be important for making Bitcoin more accessible, making it easier for more and more people to validate Bitcoin, and potentially have some privacy benefits also. So we talk about the ins and outs of this, as well as comparison with other ideas like assumevalid, assumeUTXO, and get into some of the details about utreexo, proofs, utreexo nodes, and all kinds of stuff. So I hope you find this one educational. Calvin, welcome to the show.
Hi, glad to be here.
Yeah, so I'm excited to chat. I think this is going to be an interesting one for listeners to learn a bit more about utreexo, Bitcoin scaling, and ideas like this. I know you've been working on this for a little while. Can you just give listeners a bit of a background on yourself? Who are you and what are you doing in this space?
Okay, so my name's Calvin, and I'm currently working on the UTXO project with the grant from BitMEX. I've been doing that for about 3 years now. I've been involved with the research of the project. Now at the moment, I'm more involved in the implementation of UTXO into an actual Bitcoin node. And in a few months, we're hoping to release something that normal users can use. So I'm excited about that.
Fantastic. And as I understand, this could help make it easy for people to use Bitcoin in ways that maybe can reduce the download size and reduce their bandwidth requirements. But we'll get into some of the details. So I guess let's just start high level. What is utreexo?
Right. I want listeners to take away one thing. utreexo is just a fancy Merkle tree. It's just a fancy Merkle tree. And if I go into a little more detail about that, so let's just start from the beginning and let's just talk a little about Merkle trees. How I would like to look at Merkle trees is it's just a black box, and if I could put in items to this black box, and then it'll generate something. It'll generate result, and if I keep that result, people can prove to me that this item existed in the set. So I guess an easier example would be like if there's an event and let's say there's a guest list, and if there are 4 people on the guest list, what I can do is I could make a Merkle tree out of that, and then I could only keep a very compact summary of the guest list. And each of the guests can prove to me that they're actually on the list. So if it's like a guest list of Alice, Bob, Carol, and David, Alice can prove to me that she's on the list, but I'm not keeping the entire list. So normally what you would do is you would have like on a piece of paper or something, it's like Alice, Bob, Carol, David. But I wouldn't necessarily keep all those 4 elements. I just keep this one compact summary, and Alice and everyone else brings me a proof that they're on the list. And I can verify that proof and just check that, okay, this person is indeed on this list. So that's something a Merkle tree can do, and this is really useful for, in Bitcoin it's currently used to compactly summarize the transactions in the block. And we commit like this compact summary into the block header, and that's how we know, okay, this is, these transactions in this block are indeed connected to like this proof of work. And so that's like Merkle trees, that's how it's being used in Bitcoin currently. So I said UTXO is a fancy Merkle tree. Why is it fancy? So it's fancy because it does 2 extra things. It allows you to add new things to the Merkle tree, and it allows you to delete things that already existed. So going back to the example of like the guest list, so it's like Alice, Bob, Carol, and David. Let's say, hey, I also want to invite Stephan as well. Like I think he's kind of cool, so I want him in the party. And so with the Merkle tree, you would actually have to recalculate the entire thing. So thinking of Merkle tree as a black box, now we have to get 5 elements like Alice, Bob, Carol, David, plus Stephan into the black box. So to add things or to delete things from the list, with the typical Merkle tree, you'd have to have the entire thing again. With utreexo, you don't have to do that. You just need the compact summary, and only with the compact summary, we can still add and delete things. So with utreexo, if we were to use the guest list example again, but with utreexo, we don't need to do it all over again. We just need to get our compact summary and then add stuff onto the list.
Right, so we can think of it like the compact summary plus the differences, rather than recomputing the entire thing.
Yes. I would love to have a whiteboard and go over it, but it's kind of difficult to do that.
Yeah, sure. Yeah, but I mean, let's try to put it in simple terms. So I guess today, when you run your Bitcoin node, today it's probably over 550 gigabytes. Now there is a thing called pruning. People can prune the Bitcoin node and let's say 5 gigs of space, and generally that they are holding what's called the UTXO set, the unspent transaction output set.
Right.
And so as I understand UTXO, it's kind of like we could dramatically bring that size down to a few kilobytes instead of say 5 gigabytes as an example. And so then it would be easier to, let's say, have a Bitcoin wallet and connect it with a Bitcoin, like kind of like a cut down version of a Bitcoin node, let's say. So could you just break that down for us, like the difference between, the archival node storing everything ever, then let's say, the full node, like prune node, and then like a utreexo node, if you could explain that for us?
So a Bitcoin node has like different modes per se. So you could be an archival node and have the entire history and have the entire blockchain, and also have the UTXO set. So that's one thing you can do. The UTXO set being all the currently available Bitcoins that can be spent. But what you also can do is you could just delete the historical blocks from your computer, your node. And so you could only keep the UTXO set, and you could still validate new blocks that are coming in because you already know which Bitcoins are available to be spent. And that's all the data you would need. UTXO take this a step further and says, so we're now shifting the burden. So let me get into this example. So I like the guest list example. So Alice, Bob, Carol, and David. Before, currently a prune node keeps all of the list. So if we were to imagine like Alice as UTXO1, UTXO2, UTXO3, UTXO4, I have to keep everything in order to verify new transactions and new blocks. What UTXO does is I don't want to keep your transaction. Like, I don't want to keep that. You prove to me. I only want to keep the compact summary. You bring me the proof, and you prove that you are indeed in the UTXO set. So it is a shifting of the burden from the node runner to the person that is making the transaction.
I see. Yeah.
And so yeah.
Go on. Yeah.
And I was gonna. What this allows us to do is this allows us to it compactly summarize the UTXO set. So as you said, it makes so you can now have a node that is a kilobyte because one, we get rid of like the blocks because they're historical blocks, and then two, we can also get rid of any UTXO that we don't care about. If it's not my UTXO, I don't keep the proof for it. I don't keep that data, and so I just keep my things that I need to prove to others. And others should prove to me that they exist in the UTXO set, or the coins that are trying to spend exist in the UTXO set.
Yeah. So as we were saying, it's like this guest list or club example, and say I want to get in to the club or whatever, and I need to prove to you, oh, hey, my name's actually on the list. Here's my proof.
Yep. And
you can then check. So you can see, Stephan's his name is on the list, so he's allowed in. Right. And in this analogy, what we're talking about here is the Bitcoin network allowing you to spend some coin. That's kind of what we're talking about here, right?
Yes.
So could you also, I guess while we're here, it might be also good to spell out the difference or contrast with other ideas such as assumeUTXO or assumevalid. If you could explain, I think, the assumeUTXO, is there any relation? How are these ideas different?
So assumeUTXO is it's related to UTXO. It fits in well with UTXO because with assumeUTXO, what you would do is in the binary in the Bitcoin Core software that you download, it has the root that is of the UTXO set. So there's a compact summary of the UTXO set at a certain block already there for you. And you sort of assume it's valid because it was included with the binary. You have the option to validate from 0 to that assumed UTXO set, but what that assumption allows you to do is it start immediately from the tip. And that's really the advantage that assumeUTXO has, because if a new user wants to start accepting transactions right away with Bitcoin Core, previously that had to sync up, and Bitcoin Core will tell you a message, we're not at the tip. Any Bitcoins that you receive now, it's probably not safe for you to accept them. But with assumeUTXO, there's the small assumption, but it allows you to verify new blocks that are coming in.
Just to clarify, as I understand, assumevalid is already in Bitcoin Core today.
Yes.
assumeUTXO is not.
Not yet.
So just so people are clear, listeners, so assumevalid is generally it's on by default. Now you can turn that off. It's like a flag. I think you could do assumevalid equals 0, and then your Bitcoin node will validate all signatures since Genesis, versus if you have it on default, I think it validates from like 6 months ago, wherever that snapshot was, right?
Right. So assumevalid is something where because these blocks are they're very historical blocks. They're like a couple years in the past, and so. So it's saying, let's just take out the most expensive part of block validation, which is the signature validation. So you do everything else, but you don't validate the witnesses, the signatures. And that's what assumevalid is. assumeUTXO, sort of different. You're still assuming, but you're just given like this snapshot of a UTXO set at a certain block, and you could just start accepting new blocks from that height on. UTXO, you could do sort of like assume utreexo, not a UTXO, assume utreexo, where it fills the gap, or it's with assume UTXO. There's still the inconvenience of having to download the UTXO set. So let's say so if there is an assume UTXO like commitment at block 700,000, I still need to download the UTXO set at that block height. So that's like 4 or 5 gigabytes. That's gonna take me a little while. Assume UTXO, because since it's like a kilobyte, just start right away. It's included in the binary, and so there is no waiting. You just start right away, and
Right.
that's sort of the idea that we have. It's like, hey, we could take assume UTXO a step further and have like assume utreexo, where it's even more convenient for users that are getting started.
Yeah, and as I understand, there are ways that this could be built out where you could have that new user start and be able to make and take transactions straight away, but in the background, that computer, let's say it's a proper computer, it can still be downloading the full blockchain. So it can kind of give you a quick start way that still eventually gets you to the full validation that having a full node or even an archival node, if you wish. So I guess that's one idea that one way that these could be built out.
Right.
Yeah. So when it comes to the proofs then, could you talk us through that process a little bit? Because I guess listeners might be thinking, hang on, how do I prove to you, like how's the software working such that we prove to each other, are there going to be special UTXO nodes and clients in order to work in this UTXO context? Because maybe the rest of the network doesn't know about or doesn't care about that, right?
Right. So there will be special UTXO nodes. They will have a service bit that says they understand the UTXO protocol rules. And with these nodes, so if you are a UTXO node, you will receive the block and the transaction as normal, but you will receive the proof along with the transaction or the block. So there is a trade-off in that you are using more bandwidth. So it's not free, but we think it's a very good trade-off because the advancements in like the internet speeds, it's there. We just need infrastructure for that. And whereas like disk IO, like the disk speeds, they're not really improving that much, or like the storage, I guess, costs. I could get in. So there's a couple of things that I'm just juggling in my head, and I could get into them.
But if you could just contrast then for people, let's say, I guess what you're getting at is the difference between running just a standard archival full node versus running that plus also being UTXO aware. If you could explain that for us, maybe, and then we can go from there.
Okay, so in the UTXO setting, you would have okay. So you can have UTXO nodes that are actually archival nodes. You can do that because UTXO, the only thing it applies to is the UTXO set. So if you choose to, you can keep the entire history of the blocks, but choose to prune the UTXO set.
Yeah.
So you would still be like a 400, 500 gigabyte node, except you wouldn't have the UTXO set that's like 4 to 5 gigabytes. What you can also do is you could do like a pruned UTXO node where you get rid of the historical blocks, and then you also and you also keep the compact summary of the UTXO set. And that's where like the really small nodes come in.
I see. Yeah. And so, then could you explain for us what that would look like if you wanted to have just a really small, this few kilobytes. So I guess the UTXO component of it would be the few kilobytes, which is the proof. And then would you still need to be downloading new blocks as they come in, or would you be fully operating in like a UTXO way?
Oh, so you would still be downloading new blocks as they come in. So blocks and transactions you would get as normal, except after you validate them, you can just throw them away. Just like how normal prune nodes would work.
I see. So it's like a download, validate, and then throw it away. Because what I would do is check, are there any transactions I care about, or are there any transactions that, are coming to me? Obviously, I want to keep those, and then I'll throw away the rest. That's the model?
Right. So it's just prudent nodes on steroids.
Okay, gotcha. So there's all kinds of, I think this could really open things up in terms of how many people could run a Bitcoin node. And I presume that's the idea, right? The idea is now today, there's a lot of people who don't run a Bitcoin node, right? And we know, if you look at the numbers, it's probably something in the I mean, at a guess, tens of thousands, 50,000, something like that, probably around the world today. And we're talking, maybe 40 or 50 million people today who hold some UTXO. So it's kind of like, we're talking a small number of people. And so potentially this could increase the availability or the access for that. So could you elaborate a bit on that?
So yeah, that's one of the benefits that I think utreexo brings to Bitcoin users. There's several benefits I would like to get into, but the one is that, hey, nodes are now easier to run. It's easier to run because, one, you could do like an assumeUTXO thing and just get started right away. Two, just the fact that the node is so small allows us to put nodes where they really couldn't live before. And one of the ideas that we've had was, hey, you could actually feasibly have a node running in your browser as a browser extension. So you could just have in your Chrome or Firefox, you would just download a browser extension, and that's your node. And every time you use your browser, your node is on. And so you could feasibly do that. Another thing you could also do is have a node that is bundled with the wallet client. And so you could have something like Blue Wallet, but Blue Wallet is downloading actual blocks and it's actually verifying. And it's small enough that it could fit inside it. So with the current Bitcoin set, with the current Bitcoin UTXO set, it's like 4 to 5 gigabytes. It's not feasible to have that as a browser extension or like have it embedded in some app. With UTXO, you can. And so that's one of the advantages that I see that brings to Bitcoin users. And another thing that I do want to mention is that with utreexo, it's possible to have not a node, but a client software that validates blocks. So it's a fully validating client software. So we know, as you've said, there's only so many people running nodes, and if you don't run a node, someone's going to have to run a node for you, and that takes away the qualities that we like about Bitcoin. And so if you really want those qualities, you need to run a node. But so the idea here is, what if you can validate blocks and you can validate transactions? So you won't necessarily relay them, so you won't be helping others, but can you just validate them so you gain the properties of Bitcoin that really is useful? And with utreexo, you feasibly can. And so you wouldn't necessarily be broadcasting transactions or broadcasting nodes. You would only be listening from, it could be a server or it could be from a different nodes, like it could be a P2P network, but you can get blocks and get transactions and validate them. And I think that has a real use case. And I think that will bring the security benefits and the privacy benefits of running a node into people that really can't either, they don't have the technology, they don't have the knowledge to do so, or they're just not bothered to do so.
Right. And so coming back to that example with a browser utreexo node, would that also work in a Lightning context? Basically, I guess the question I'm asking is, can utreexo work alongside a Lightning for a Lightning user?
So I have talked to a few LDK people about this back in Atlanta last year at the Atlanta conference.
Yep.
Yeah, at the TAFConf, and I'm not quite familiar with the requirements that Lightning nodes have from a Bitcoin node. But what I did hear was that like something like LDK has the option to connect to like an electrum background. So if you have some sort of like electrum server thing running, you can connect LDK to that, and then you'll just have like a Lightning node working. What I am working on, and what the release that we have, the release that we're doing in a few months, what it will include is the option to have an electrum server going for you. And so it'll be something like an electrum personal server where it won't index every single address in the world. It's just it'll index your address. So you'll give it like your pub key, your extended pub key, and it'll generate addresses and it'll keep track of your addresses. And so feasibly, yes, you could because it will support the it'll have Electrum support out of the box. You can connect your Lightning nodes to it, or like something like LDK to it, and have it working that way.
Right, yeah.
I'm not quite sure how. Yeah, so my Lightning knowledge is not good enough for me to answer. Hey, like,
right.
will
Would
this
it work
work
with
out?
Lightning or not? Yeah. But I mean, it might make more sense in the on-chain environment than, let's say, you just want to be able to quickly. I guess in this example, if you're trying to have it with a browser, you might not really want the private keys in the browser, but it might be like a watching thing, or it might be like a way for you to. In the same way that you have like Spectre or Sparrow or one of these things where the hardware device is separated from the, but the wallet or the let's say the transaction viewer it could be in a browser, let's say.
Right.
Maybe that's an example of how it could look.
Yeah.
So how does it work then? So I guess if it's a few kilobytes, what we're talking about is in the UTXO world, let's say we're doing UTXO, it's a few kilobytes or 1 kilobyte. Does that mean you also need to store every transaction you're involved with? So that's kind of the real storage requirement.
So there is a catch to like the kilobyte thing. The kilobyte is only for the UTXO set. So like the UTXO set that was 4 to 5 gigabytes, it's now a kilobyte. The real kicker, or the real problem is that the headers are bigger than a kilobyte. Like the entire headers that you would download. That's bigger. Like your peer database, like you keep a database of like which peers you're connected to. That's bigger than a kilobyte. If you have like an Electrum personal server going, you're keeping the relevant transactions and the relevant information with them, and that's way bigger than a kilobyte. And so there is a catch, yeah. So the node itself, it's a kilobyte. But if you want to do like I guess stuff like wallets or be able to actually use the node so that you can connect your wallets to it, it's going to be bigger than a kilobyte.
I see, yeah. So where do you see the most practical uses then? Is it mobile users? Is it, just random web users? Like where is the most practical use case going to be for utreexo?
I'm really excited about like the client side Bitcoin validation part. And so because we don't really have that at the moment. It's like, hey, go run a node, but I can't tell my mom to go to run a node. I don't think she'll be able to. It's very difficult for there are people that would benefit a lot from the properties that Bitcoin has, but you don't get those benefits if you don't run a node. And that's a real deal killer for a lot of people. And I think that's stopping a lot of people from actually taking advantage of the properties that Bitcoin has. And so I think that the client aspect of utreexo is something that I think is really exciting and something that I think will help a lot of people.
This show is also brought to you by CoinKite.com. CoinKite.com make a range of Bitcoin hardware and accessories, most notably the Cold Card Mark IV. So the Cold Card is an excellent device. I find it really reliable, and particularly important is the idea that you don't have to phone home to use it. You can just plug it into the wall, you can spin it up, you can generate your seed words, you can then use it with wallets like Spectre Desktop, Sparrow, Electrum, or others, and you can use it in all kinds of configurations. There's all kinds of different pins and configurations that you can use to help secure your Bitcoin for the long haul. So go to coinkite.com. You can find a range of gear there, whether that's the cold card or the tap signer or other material, and get a discount on your cold cards with the code Livera. Build on L2 is a community initiative for Bitcoin builders by Blockstream. This is particularly important if you are interested in Core Lightning or the Liquid Network. There's a range of technologies that they are discussing on the community forums. You can see discussion about things like confidential transactions, Miniscript, liquidity ads, green light, and all kinds of stuff. This is an interactive community platform where if you are a builder, a product manager, a designer, an engineer, or just an interested person, you can find out more. There is a mentorship program, there are events as well as discussion forums to learn alongside other Bitcoiners. So go sign up. It's over at buildonl2.com. And lastly, Unchained Capital. Unchained Capital provide security services to help you secure your Bitcoin, and they do it in a way that's secure, transparent, easy to use, and sovereign. You can create a multi-signature vault where you hold 2 keys in different locations and Unchained hold the 3rd key. They can even help you walk you through the process with a product called Concierge Onboarding. So you can buy this package, you can pay up front, they'll ship you the devices if you need them, and they'll do a call with you to walk you through the process of learning how to become self-sovereign and remove single points of failure in your multi-signature setup, in your Bitcoin security setup. And this can give you that additional peace of mind to know that one mistake is not going to totally screw you over. So go to unchained.com, click Concierge, and use code Livera for a discount there. And now back to the show. Okay, great. And so let's talk a little bit about the trust assumptions here. So could you help us understand what kind of trust assumptions a UTXO user is making versus not using UTXO?
So UTXO is a full node. I think people sort of confuse this a lot and think UTXO is like an SPV thing. It's a full node. It has the same security as a full node, but it's consensus-wise, like code-wise, it's a little different. So a normal Bitcoin node, when it stores the UTXO set, it uses something called level DB. So it uses a database and it uses something called level DB. So consensus is sort of defined partly by level DB. And I'm not saying that there is, but if level DB has a bug, then, and let's say some UTXO doesn't exist, then that is consensus by definition. With UTXO, you don't have that assumption, but you have the UTXO proof model assumption. So it's different. So you're not, I wouldn't say you're necessarily giving up any sort of security. You're still a full node. You're still validating every single block and every single transaction that you're getting, except that if there is a consensus failure, there's going to be a split. And so that is something that users, that is a risk that users will have if they run UTXO.
Yeah. And to be fair, that would be the same risk as if you are running libitcoin or BTCD or
right.
NOTs or something like this, right?
It'll also be the same risk versus if you're running like an older version of Bitcoin Core. So if you're running like Bitcoin Core 21, it's different from 24. And so you could argue that, I think it's fair to argue that, hey, like this is much bigger of a change than different versions of Bitcoin Core, but that there is a risk that is carried when you switch versions or have run a different node software or something like that.
So I'm also curious, are there any interoperability concerns? Like, could it ever fall out of sync with Bitcoin Core? I guess that's what you're saying. Like, theoretically, it could fall out of sync with Bitcoin Core, and then those users could be like kind of up the creek without a paddle, theoretically, of course. I mean, as another example, could we see what happened? I'm sure you were seeing what happened with BTCD and Barack with those LND transactions. That, as I understand, it was like the way the transactions were being passed over the wire compared to what was a valid transaction to be in a block or in a transaction. So, could a similar thing like that happen?
I'm not saying that there is a bug, but let's say there is a bug in the UTXO implementation, like the actual, like the Merkle tree side of things. If there is a bug there and it says that, hey, like this proof for a block is invalid when in reality it really is valid, but it's just an implementation bug. Yeah, it's something like that could happen and a fork could happen. But I want to say that is the same risk you carry if you're running something like libBitcoin, like BTCD, Bitcoin. It's just there is the risk of different implementation, like different node implementation, but you're not really fundamentally giving. You're still a full node. You're not becoming an SPV node.
Gotcha. Yeah, and I think that's fair, and I think it's I think it'll be interesting to see if if UTXO enables new kinds of users or clients, like you said, a validating client idea that, let's say, our mums and grandmas could be using Bitcoin in a more self-sovereign way than, let's say, you or I or the listeners of this show maybe are probably more inclined to be able to, or at least be able to run their own thing and do their own thing. So, yeah, I think that'll be an interesting aspect. What about... So, in order to be a utreexo node, we're still relying on enough people who are running like proofs, right? Or enough people who are serving up.
Yes.
Like, do we need there to be enough, let's call it like utreexo servers, let's say, or it doesn't really matter?
We call them bridges because...
Bridges, okay, yeah.
So the proof, someone needs to provide the proof, and those... we can sort of soft fork in that, and so say, hey, the proof needs to be included in the Coinbase transaction. We're not going to do a software.
Right.
So no soft forks, but you need these bridge nodes that take in blocks from the existing Bitcoin nodes currently and make UTXO proofs for them. And so we need these bridge nodes to be running. And so if you're like a UTXO node that is like a kilobyte, we call them compact state nodes. And so if you are this compact state node, then you need these bridges up and running to be able to validate new blocks. So if a new block is there and there are no bridges at all, then unfortunately you won't be able to verify that new block. So there is a new data availability sort of a trust assumption. It's not different. Well, in my opinion, I don't think it's different from the assumption that a prune node has versus an archival node. So let's say a prune node, something goes wrong and you need to re-index, you expect there to be enough archival nodes for you to be able to do that. And so I don't think that's a different model than the current one that we have today versus archival and prunes. Versus so archival nodes would be like akin to bridge nodes, and like the prune nodes would be akin to compact state nodes. One thing I should mention is that these bridge nodes can also be pruned. So you could be an archival bridge node, or you could also be a pruned bridge node. UTXO only applies to the UTXO set. So when I say bridge, you are a bridge in the sense that you're bridging the UTXO set and the UTXO people, not the pruned or archival sense.
Right, I see. Yeah, it's like a confusing... Yeah, you're right. So basically the point we're talking about here is the distinction between the UTXO set and the blocks.
Yes,
because you can be pruned and not care about the old blocks, but the UTXO set is a requirement regardless of how... Like, if you want to use Bitcoin full stop, you need to access that. You need to use that.
So we're introducing two extra sorts of node modes. So right now there's really only two, right? Archival, pruned. You could be a compact state node that is archival, and you could also be a compact state node that is pruned. You could be a bridge node that is archival, and you could be a bridge node that is pruned. So four new extra modes of Bitcoin.
Gotcha. And I mean, of course, we're early days right now. Could you tell us a little bit about what state this is in today, and just explain a little bit about where we are today?
Okay, so some of the stuff that I did early on was there were a lot of research stuff going on as well, and so we've figured out new algorithms to have to be faster and to have less to require less bandwidth for the proofs, so smaller proofs, and that part, like the utreexo, like the Merkle tree stuff, it's all good. We're good to go, and I haven't wrote up a spec for it. I haven't wrote up a bit for it, but we are able to write a bit for it. Everything is complete. What is not complete is the P2P layer part. And so how like the messages would work. So how would a block message look like with UTXO proofs? How would a transaction message look like with UTXO proofs? That part hasn't been fully fleshed out yet, and that is what we're still working on. But besides that, everything is really complete and good to go.
Okay, yeah. And so this is, I think I saw an email on the Bitcoin dev list. You said using service bit 24. So this is the idea to start in the testnet and signet. And so the idea is eventually, like once it's all good, and let's say it goes to mainnet, all the nodes are just out there and they can easily talk to each other just through the peer-to-peer protocol of Bitcoin in a decentralized way. That's the goal, right?
Yes, that is the goal.
Yeah. Okay, great. So in terms of timing, could you tell us what are you looking at in terms of like having? You mentioned a binary that's
Yes.
going to be available for people.
So we could have just released something months ago, but we're just like, okay, it's just a node. It's not doing anything for users. It's not like that you could connect your wallet to it or whatever. And so one of the things that we were talking about was that, hey, we really need some sort of a wallet for this. And so what I've been working on for the past few months is this Electrum server that connects to a watch-only wallet with the binary. So when you start up the node, it'll ask you for like extended pub key, and if you give it that extended pub key, it'll take that in, and then it'll create like this Electrum personal server, and you could connect any sort of wallet that uses the Electrum protocol. So I've been testing on Nunchuck and the Electrum wallet. There's some kinks still to be worked out, but most things are working. And so we're not quite there to the finish line yet, which is sort of disappointing for me to say, but we're getting very close. And it won't be something like, hey, like this is out there and it's just a node, it doesn't do anything useful. It'll be something where, hey, like if you run this, you'll obviously have to be a power user because it's just the binary, and you'll have to configure like the port settings and like port forwarding and stuff. But for power users, it could really play around with this. And so at the moment, I've had Signet connected, and I've been using the Nunchuck wallet and the Electrum wallet, and I've been able to send broadcast transactions, receive Bitcoins, and fully be able to prove them. And so, well, to be fully able to validate them, sorry. And so it's working. I'm excited. Excited to get these in the hands of users soon.
Yeah, and one other question: when it comes to putting in an extended pub key or XPub, can we also do like multi-signature? So let's say I'm running a 2 of 3 multi-signature. Do I need to put in all 3 public keys, or like how would that work?
You would need to put in all 3 public keys.
Like an output descriptor, as an example, right?
Yes, I've not had the time to deal with that yet, so it's not supported. Only single sigs are supported, but
But eventually, the goal
yes.
would be that you could do that kind of thing. Yeah.
Yes.
Okay, gotcha. Yeah. Okay, cool. So I guess what we're seeing is this could be like an Electrum personal server model. And so as we said, it's an availability concern. So it's not a trusting concern. It's a data availability of, are there enough bridges, or so I guess, let me make sure I'm understanding this correctly. If we want to operate in a UTXO model, let's say I'm just an average user and I'm not really able to run a full Bitcoin node today, and I'm like, oh, hey, Calvin, this sounds cool. Let me do this UTXO thing. Let me be a compact state node. What I'm relying on is there being enough bridge nodes, right? That's basically what it is.
Yes. Are there enough people running nodes so that I can get proofs for them?
Gotcha.
That is your concern. Yep.
Right. And so let's say I'm that user and I want to do a UTXO compact state node, and I want to run kind of an equivalent of an Electrum personal server. That's the concern. It's just as long as there's enough bridges. I presume you're going to run one, and there'll be a few other enthusiasts who are running the bridge nodes to kind of be the seeds to get it started, or get people, help people start. And then the goal is that more people can be a client-side validating, or like a validating client is probably the best term to use, right?
Right.
Okay, great.
I should add one thing. I've seen this like data availability concern a lot, and one of the things you can do to solve this problem is you could just software it in, and so you just make sure every node is carrying the proof and like have the proof inside the Coinbase TX, and so you can solve it by just forcing everyone to keep it if the demand really gets high enough.
If the community wanted that, and let's say there was lots of users who use UTXO compact state nodes, then maybe there would be a discussion in the community of, hey, do we want this because as I understand, it would only be a little extra data and a little extra computation on the full nodes, right?
It's full clarity. It's not a little extra data. It's like 1.8. So if a block is 2 megabytes, the proof will be somewhere around it depends, but it'll be like 1.3 megabytes or something.
Okay, gotcha. Okay, so it is a rise or an increase in the bandwidth, let's say. So that's what the bridge storage. Nodes. Yeah. So that's what the bridge node has to take on, let's say,
right.
so that the compact state nodes can be served the data.
So I want to make this clear as well. And so you could be a compact state node and be an archival node and have the proof stored for historical blocks. Bridge nodes, the only thing they do is, well, you can be like an archival bridge as well, but bridge nodes, their role is to convert, so in a world if we started at Genesis with UTXO, we wouldn't need bridges. But since we didn't do that, we need these bridge nodes to generate proofs for incoming blocks, because blocks are created without UTXO proofs. So we need some of these nodes to create those proofs. And once those proofs are created, like CSNs can store it, like the compact state nodes can store it. And so for historical blocks, you can either be a bridge node, you could be a compact state node and have the proof for that block. It's only for generating new blocks and new transactions. So it's only for generating proofs for new blocks and new transactions.
Yeah. And one other thing I've seen, so some of the blog posts and things I've been looking at, it seems to, well, maybe this is just done for the sake of example. Maybe you could help explain that for me. It's like showing at block 600,000 and block 700,000. Is there a reason for that? Or is it just more like let's say we're in UTXO world, are they generating a new proof every block, or is it only like certain big blocks and then they calculate a difference? Or how can you explain that for me?
So I think you might have read like the BitMEX blog post, but
there was I think it was called out of order block validation.
Yeah. So that was a fun researchy thing that I've did during my first and second year of working on the project. And so to answer your question first, for every block, a proof is generated.
Right. Okay.
But we also have the option to generate a proof at like every intervals of 10. So like at block 10, we generate a proof, but we generate a proof, and you as a compact state node have to cache things in between. So that's like a caching optimization. Is not fully fleshed out. So there are also ideas that we have to reduce the amount of bandwidth that nodes have to that they have to burden. And so I think some of that might be related to that.
Okay, that's probably my confusion. Okay, gotcha. No, thank you for clarifying. Okay, cool.
Yeah.
So go on.
Yeah, so I wanted to get to like the out of order stuff, and so. One of the fun things that we figured out you can do is if you have like these tiny states, like the tiny UTXO states, what you can do is you could just start validating blocks from that point on. So if I give you the UTXO, like the UTXO roots we call, like so the compact representation. If I give you the roots at block 500,000, you can start validating blocks. You can start validating block 500,001. So I could give you the roots at block 100,000, and you can validate block 100,001. And so what this allows us to do is it allows us to validate blocks out of order. And this opens up to validating blocks in parallel. So in normal IBD mode, you have to start from Genesis. You have to start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. But so this also goes back to assume utreexo. So if we assume utreexo every 10 blocks, so assume utreexo block 10, block 20, block 30, block 40, then we can parallelly validate all these blocks at once. And that has potential to massively speed up IBD. And the blog post that I wrote up, I did benchmarks, and I have forked BTCD, and my fork of BTCD with this idea was able to sync faster than Bitcoin Core at the time, and was about 63% faster. So it's not really an apples to apples comparison, because BTCD normally is much, much slower than Bitcoin Core at IVD. And so, have the same thing in Bitcoin Core, and it'll be able to dramatically speed up how long IBD takes. And so that was one of the
so this is like an extra pros, yeah. This is extra credit, right? This is kind of separate from the base UTXO idea, right? Just to be clear what we're talking about, right?
Right.
Okay. So So do you want to? Do you see any other, implications for the the community, the ecosystem of people using more people? Let's say lots of people start using UTXO. Do you think that changes any other dynamic about Bitcoin, or not really? It just means more people can validate.
The problem that I see, the problem that I see today is that not many people are getting the benefits of being self-sovereign. Like the whole point of Bitcoin is that, hey, it's you can validate. It's like you have this the supply limit, and you can validate this limit. But if you're not running a full node today, you're not validating those things. You're trusting a third party to do that for them. And so you really, really want to run a node if you want to take full advantage of all the properties that Bitcoin gives. And so what I think UTXO will allow people to do is, hey, if I want mom to have be self-custodial and be self-sovereign, hey mom, go download this app, and the app is a wallet, but it doesn't reach out to a electrum server and you give all your data to them, except what you would do is you would just download blocks as normal, and you would have all the advantages, all the advantages that you would get with the full node, in that you validate everything, you have the privacy and those things. And so I don't see UTXO as something that changes fundamentally how people perceive Bitcoin, but it brings the existing qualities of Bitcoin to more people.
Yeah, that's a great way to explain it. And I think it is also worthwhile elaborating a bit on the privacy benefit, because could you explain a little bit about that? Like, I guess today, if somebody is using a public server, or look, a lot of people today, they leave their coins with an exchange, with a custodian. Like, that's like the worst of all worlds.
Yeah, that's the worst.
Then maybe the next step is people just get a wallet, and that wallet is calling out to somebody else's server. Yeah. So I guess in a UTXO world, do you see privacy benefits for those average users?
Yes, and that's because, the worst case, you're on Coinbase or any other centralized exchange, and they have all your information. They KYC'd you. They know everything about you. They know your face, your address, whatever. That's the worst. I guess a step up from that is self-custodying your coins, and that's good, because now Coinbase just can't, or the centralized exchange just can't run off with your coins. That's good, but you still have the privacy implications in that for most wallets, they just connect to a public Electrum server. And what you would do is you would give that Electrum server all the addresses and here is all the addresses that I control. Please tell me if I have coins. And hey, okay, so the server tells me I have coins. Okay, please send me the transaction. And you're revealing a lot about you. And we this is also sort of a speculation, but like we know like something like like chain analysis is running a lot of electrum servers because it allows them to track. It gives them extra tool. That's an extra tool for them to break people's privacy and keep track of like who owns which address. This IP controls this, and it's very. It's not good in the privacy perspective. And so,
so I think that's probably an angle that you could really get out there and promote. You could sort of say, hey guys, look, many of you currently today are just giving up your full privacy when you use Bitcoin. Whereas if we had UTXO, you might be more private from chain analysis and other surveillance entities out there.
Right. And I guess another thing that I could mention is that Electrum protocol depends on SPV proofs. And so you only have SPV security. It means that if enough miners are dishonest, then they could have a longer proof of work chain, and then like they could fool you with that. They could potentially fork you off from the main chain. So you would be an SPV proof, you're really trusting the miners. With UTXO node, you no longer have that assumption because you're a full node. So you also get that additional security benefit.
Gotcha. I'm also curious I don't know if you've run any benchmarks on comparisons of the overall bandwidth. So let's say to be a UTXO node, or in this case, I guess a UTXO bridge versus merely being a Bitcoin archival node with like not caring about UTXO at all. I'm curious if you have any numbers for us or any.
I don't want to. Well, I have concrete numbers, but I don't want to say they're final because there's a lot of optimizations that are ideas at the moment that we haven't really got to implementation. We haven't really got to implementing them yet, and so at the moment, the worst possible during IBD is 2x. So normally you would download like 400 to 500 gigabytes. With UTXO, you would be downloading like 800 to 900. It's a little less than that, but it's like about 2x. So that's like the maximum. It's like, hey, how worse will it get? How much worse will it get during IBD? It's like 2x. When you're all synced up and when you're receiving transactions, the worst case is you receive. So if receiving a normal transaction is like 100%, you would be doing 400%. So let's say if like a transaction is, I don't know, a kilobyte, then it's like you'll be getting 4 kilobytes instead of 1 kilobyte.
Okay.
So that is the absolute worst case. So I want to re-emphasize that there are many optimizations that we haven't implemented yet.
Yeah. And so what would you say is likely? Let's say if let's say IBD is 2x as bad and syncing is 4x as bad from a bandwidth point of view, what would you say is the likely, at least given what we know today?
So it really depends on how much you want to cache. If you want to cache more things, so like if you have more RAM on your system, then you can dramatically reduce the amount of things you will download. And that goes for IBD, and that goes for when you're getting transactions. Yeah. And so it's really hard for me to say. Yeah.
Gotcha. Yeah. And to be clear, we're talking about in the bridge context, right? If you are just a...
This is for bridge and compact state nodes.
Okay, gotcha.
So
okay.
For both.
And then you...
Oh, wait, sorry. For bridges, you wouldn't be downloading, so you would be normal Bitcoin node. So you wouldn't be downloading anything extra, but you will be serving extra things to other nodes.
Yeah.
So you will have that,
Right, because the whole point, I was confused, because the whole point is that the compact state node doesn't have to... Yeah. Gotcha. So the idea is if you want to be a bridge and help other UTXO users, you're paying a little bit more, let's say, but the compact state node, mom, doesn't have to because she's just using in her browser or something like this or some like cut down application. And who knows, maybe in the future we see some of these existing wallets and applications come out with UTXO support. So as an example, let's say if Nunchuck had UTXO support, or if, Sparrow or Spectre had it, maybe that's something there that you could tell mom, hey, use this, but put it in UTXO mode so you don't have to download the full chain if you think she's not capable, etc.
I would love that future. I look forward to a future like that.
Well, let's see. I mean, I guess it has to kind of get proved out, but I guess that's the goal, right?
That is the goal.
Yeah. So I guess we've spoken a bit about UTXO. Is there anything, I guess, broader, like in Bitcoin, Lightning, or whatever else that you see you're interested in, or you would like to see?
I've been pondering this for a bit, and I was like, okay, if I get done with UTXO, I want to do Electrum Protocol v2. There's so many things that are very inefficient with the Electrum protocol, and I just haven't noticed as before because, it works fine, right? But actually doing the implementations of like the Electrum personal server on the UTXO node, it's like, oh my God, why are we doing it this way? This is so ridiculously inefficient. It doesn't need to be this inefficient. And so that's why I was sort of thinking, hey, like we're doing like Stratum v2, right? Why not Electrum v2? So that's
so
what I would
what kind of improvements do you see? Like, would it be like at the indexing size or at the bandwidth level, or
all levels? It's like you don't need to send. So one of the things that I think is really frustrating is that when you ask to the Electrum server, like how much Bitcoins do I control? You don't give the address, but you hash the PK script. So you hash the script and then you give that hash to the server and say, hey, if there's any updates to this hash, then send me a status update. And status is the concatenation of every single transaction that has happened for this address, and it sends that over. And so every time there is so if your address you're using and you're running an Electrum server, you're hashing all this thing. Every single time something new happens. And so for this address, if something like if a transaction happens in the mempool, that is a hash. If all these transactions get confirmed in the block, that more hashes. And so and this hash really only provides very little data. It provides whether something happened or something didn't happen. Sorry if I'm going off on this. So.
No, I actually find it interesting. Yeah. I mean, I've been using Electrum for a long time. I've used various different Electrum, but I'm not a developer, right? So I haven't looked into I've just blindly just kind of used it, right?
So for you, So for you, when you're running an Electrum server, you're doing all these unnecessary hashes because the protocol itself sucks. And so there's no reason for you to do those hashes. And there's also no reason when the server sends a status update, you will ask for all the transactions that has ever happened. Even if you have them, you will ask for them. There's no reason for you to, use up the bandwidth. And so this is the stuff that I see as very annoying and that could use just to overhaul and do like an Electrum v2. So that's probably what I would want to get to once I get finished with UTXO. But, yeah,
that's cool. What's interesting. I mean, it's a perspective I haven't really heard, to be honest. So, hey, good on you for finding that kind of stuff. And, I wonder. Yeah, I mean, part of me is thinking maybe it's like a Chesterton's fence thing. Maybe some of these things they exist for a reason we don't understand, or they were put in maybe. Yeah, but
years ago, and just no one bothered to fix them.
Yeah, or I guess the Chesterton's fence thing is that it exists for a reason that we don't understand, and then if you take it away, then maybe I don't know.
Oh no, it's definitely not that. It's definitely not that.
So really, they really could
there's
save
no reason.
A lot of bandwidth, a lot of effort, computation, I guess. Yeah.
Actually, one reason you could be doing that hashing is because Electrum X is meant to support Bitcoin and Bitcoin Cash. So when the protocol was originally made, it's designed to support Bitcoin and Bitcoin Cash. So it might have had something to do with that, but I mean...
That's not a reason we care about. So.
That's not a reason we care about.
Cool. Well, okay, so look, let's wrap up. I guess... We've spoken about a lot of stuff. Let's just try to summarize and make sure everyone's following along. So UTXO, let me summarize how I see it, and you tell me if I'm getting it wrong or right. So UTXO, we can think of it like a way to dramatically compact the UTXO set, right, which is about 4 or 5 gigs today. It could dramatically increase the availability for people around the world to validate Bitcoin as opposed to just trusting. It could improve the privacy. But the downside is, let's say, at the bridge level, somebody's got to be serving this up, and for them, they're paying a cost in terms of extra bandwidth, extra, hard drive, etc. But given what we have today, it might be beneficial overall from a privacy and a validation perspective. So I guess that's kind of how I would summarize it. It exists today in testnet and signet, but we're hoping that it can go to mainnet with a binary, as you mentioned.
I'm testing on testnet and signet. There's no really nodes that are out there, but that is coming soon.
Fantastic. Okay, so for anyone who wants to find out more or get involved, what's the best way to find out more or follow you online?
I am on Twitter on Calvin Alvin. That's like K Calvin Alvin with an extra N at the end. Kind of confusing. You could just search Calvin Kim Bitcoin and like some BitMEX thing will pop up, and you could follow me through there. Yeah.
Fantastic. Yeah. Well, thanks for joining me today and explaining utreexo for me and for the listeners. I
hope I was articulate enough for your listeners to, benefit.
No, I think you were. I think it was good. I think we'll have to. I might have to listen again, but I think it was good. So yeah, thank you.
Well, I'm glad.
So if you learned something there, make sure to share the show with family and friends and get the show notes over at stephanlivera.com.